Hi everybody, my name is Joe Pavitt. Welcome to this tutorial on procedural sci-fi Dune buildings. What we're going to be building today is this in front of you. It's going to be geometry nodes driven, so eventually we'll have all of this, but don't worry, I'm going to walk you through it so you can follow step by step. And on this right hand side we have a collection of different parameters that we can use to control this shape. So for example, we can change the cutout count, we can change the height of the building to be shorter, we can change the padding in the steps, something like this. We could change the cutout height and make the cutout smaller. But yeah, hopefully you get the idea. Lots of different things that we're going to do. I'm going to walk this step by step. This is all broken into chapters, so if you do want to jump to a certain part as well, you're also more than welcome to. But yeah, thanks for joining, and I hope you can follow along. So this is going to be the beginner tutorial. We're going to go through this fairly slowly, maybe over-explain a few things, but hopefully we won't miss out any details accordingly. So the first thing we're actually going to do is get started with our base shape, default cube. We can use that. We can go in our modifier, add geometry nodes, and we're actually just going to switch to our geometry nodes tab across the top. So we get our nice drop down here, add some new geometry nodes, and this is where we're going to get started. So top right hand corner is what we're seeing. As we add things in here, this will automatically update. And the first thing we're actually going to do is build that base shape. And the way we're going to do that is actually via a curve. So if we go in here and search, we want a quadrilateral. We're going to drop that in. And then we are going to have curve to mesh. And the quadrilateral is going to be the outline shape, the base shape, and then we're going to extrude that up a curved line. And the reason that we're doing this, rather than just adding a cube, for example, is it allows us a really easy way of being able to get taper. And the way that we can do that here is also set curve radius. So we're having a curve here. So if you click Control Shift and then click something, it shows you a preview of what this thing looks like. So we have our curve, which is going to define our height eventually. So that will be controlled by height shortly. We're then going to set a radius on that curve, which let's just say 1 for now. And then we can do curve to mesh for that curve. And what we're seeing here is actually I get rid of the profile curve. It's got nothing. It doesn't understand how to extrude, but it's going to extrude with a given profile. And a quadrilateral is just a square. And now we have a nice quadrilateral extruding up. And that radius is consistently 1. If we change it to 0.5, it gets narrower and so on, right? And then we can also control that via here. I'm just for the simplicity of things going to make width and height 1 here. Just because that's going to be a little bit easier to work with, and then radius we're also going to have 1, just so we've got some nice kind of simple numbers to work with to start. What we want to have is the curve and all of these parameters we want to be driven so that you get options on the right hand side in our geometry nodes. And the way that you can do that is by adding to this group input. So with group input selected, you can click N, or there's a tiny little arrow just there that you can click, which gives you the same interface. And in our group we have inputs and outputs. So for our first input, we're actually going to have height. And that height is going to be driving essentially the length of this initial curve. So the longer this curve, the taller our building will be. And that's driven right now by the end point of our vector. So here we can go combine x, y, z. And so that means we can just define z, x and y 0, and that is going to go into our end. Now notice that curve disappeared straight away because I'd set the default for height to be 0. If I set the default to be 0, we don't ever want a negative building, and for now let's just say a maximum of 10. And now when I increase my height, that curve goes with it. So for now we're just going to start off with a nice height of 1. So with that done, we can then look back at our thing here again, just to sanity check. Height goes up, so does the height of the whole building. And the next thing I want to do is add a taper. So by taper, what I mean is it will be narrower or wider at the top in comparison to the bottom, rather than just having a solid radius of 1. And for that, we're going to have a width of input. So we're going to have width at the bottom, and we're going to have a width at the top. And similarly, let's just do default 1, go from 0 to 10 as an arbitrary number for now. And helps if I put type in there. And again, standard default, just go from 0 to 1 to 10. And what we're going to do with that is we're going to map that as a range. So we want to interpolate between whatever the bottom is and the top. We just define the bottom of the top. Blender can work out the rest in the middle. And the way we can do that is with a map range node. And what that allows us to do is take in a value. And what this value is going to be is a property for our spline, our curve here. So our curve goes from 0 to 1, and we can actually see that up in this top left-hand corner. We have 2 points in our curve, 0 and 1, and these are the coordinates for them, 0, 0, 0, 0, 0, 1, 0, 0, 1 being this point up here. We have a spline parameter, which is our factor. Factor 0 at the start, factor 1 by the end. And that's what we're going to use to drive our map range. When it's 0, it will currently be 0, and when it's at maximum, it will currently be 1. So if actually I just put this in by default, and have a little look at what we get out, we get 0 at the bottom, 1 at the top. We don't quite want that. We actually want to have our width defining our minimum, which is going to be the thing at the bottom, and our width here defining the top. And currently it's 0 and 0, so if we just do 1 and 1, we get a square. If, for example, we want our top to be half the size, we then go 0.5, and we get a nice little output there. Also, you may notice this odd shading thing going on. The way you can get rid of that is you set shade smooth, and that just then basically treats edges like edges, and automatically kind of handles a lot of the nice stuff for you. So if we output that as our geometry, we don't want it smooth, we want it flat, and then that gives you flat surfaces rather than trying to think that that's a curved corner. So we're nearly done with our base shape. What we're actually going to do is we are just going to click fill caps. That's something that we've missed here. We know buildings have roofs. Won't see the bottom much, but it's nice to fill both sides anyway. And the last thing we're going to do is allow for us to control kind of little curvature on these corners. So rather than just having flat rectangular building or a flat tapered building, we're actually going to add a radius. And the way that you do that is with a node called fillet curve. So fillet curve will allow us to essentially add border radius. I generally come from a web dev background, so I'm used to the word border radius. But yeah, that's what we can use instead. And so now you'll notice straight away it's chopping off the corner. We can reduce that radius, and then in addition to that, we can change it to poly, and then have a higher count here. And what that does is it breaks it up into lots of different bits. And then that makes it much easier to define a smoother radius, should we say. So for now, let's just do 16, just so it gives us something that's smooth enough. And then the last thing we're going to do is also have our radius here driven by another group input. And you can keep pressing plus. The other thing you can also do is just drag something down there, and that will just take the default as whatever the property is that you've dragged it across to be. So our radius goes from 0 to, let's just do 1 for now, and then again we can control that from that side, and it gives us a nice rounded taper, where we now have the options to control height. We can control the width on the bottom, the width on the top, and the radius, where actually we can go a little bit too far, but if you click limit radius, it prevents that from happening. So if you're ever changing this and you don't see any change, that's why. Just go smaller. So now with our base shape defined, I'm just going to make the nodes a little bit neater to look at. So you can drag across all of this and hit Control J or Command J if you're on a Mac. And then this gives you a nice little frame or a group to work with. And you can just change that here. So this is now our base shape. Now from our base shape, we then are going to add a little roof on top as a little bit of extra detail. And the way we're going to do that is we're going to select the top face and extrude it. So what we want to do from there is we are going to do a selection of just that face. Now if I click this, which you can see it in the viewer, we've got a bunch of vertexes and edges and faces here, and they all have data associated with them. And what we're actually going to do first off is add a new node, which is Shift and A. We should have explained that earlier for those that are new, and we can do a compare. And what this will do is take in a position of each of the corners. Now by default that position actually is the position of each vertex, and we can separate that out, and what we're going to do is we're going to separate that and compare that against the Z axis, right? So you have the green axis here is Y, the red axis here is is X, and then the blue axis, which you don't see here, but it's actually shown up here, is Z. So we want to check basically any of the coordinates, because we define our height quite nicely for us. We want to say, oh, actually, just get me the vertices that have a Z of equal to our height. So we're going to go float equal, and the input is going to be our Z-axis of each vertex for A, and the thing we're going to compare against, we're just going to grab input, group input, it just goes and makes a little duplicate of this thing over here. And we want to compare that against our height. And then the result, you'll notice this is thing called is pink, and we can actually duplicate elements. And in theory, we could just extrude directly, but I quite like having a little duplicate of this just so it's a separate object. And we're going to say, I just want to duplicate this selection of all of our geometry. And then what that will do is, you'll notice, just get our vertices, which is not ideal. We would want more than that because I've clicked point and not faces, which is the thing we actually want to duplicate. So now if I click face, we end up getting the whole face instead of just the vertices in the corners. Now after we've duplicated, what we then want to do is extrude. Conveniently, there is an extrude mesh. Extrude will just add thickness to this piece, basically. So we want to take the geometry in here. I'm going to extrude our face, and our offset scale is basically how much we're extruding by, which is definitely going to be way too big here. We don't want to be extruding by a 1, but let's just say for now we'll do a 0.2. But again, actually, let's have that driven. So driven by group input, shift these things up and out the way, and then we can have a new input coming across, and that is going to be, rather than offset scale, we go group, scroll down, offset scale, we're going to have as, let's just go roof height, and a default, yeah, 0.2 is fine, but we'll change it in a second, and we don't really want to go that big with it. And now we've actually got two different shapes. We have our base shape and we have our roof, and that base shape will sit on top of the roof. And to combine them together, we can do a join geometry. And that will take two different shapes, merge them together, and so then you just have a single output. So if we take our geometry from down here, add our join geometry, and now we have our base shape with a roof on top, and we can control that roof height. And notice, because I set a minimum, even if I drag all the way to the left, the smallest it will ever go is 0, which is quite a nice little feature. I would now have a little roof on top just to add a bit more detail. And I'm going to do one more thing with this roof, which rather than just having a flat block, I'm going to allow us to have like a little inset to it. And you would have seen that at the preview at the start of this video. Just adds a nice little bit of extra detail where we want to take our extruded mesh. We're going to duplicate it again, so actually I can just duplicate the duplicate elements. And we are going to then make a boolean, and a boolean will subtract one shape from another. So what we want to do here is we have our main shape, we now have a duplicate of that. We want that duplicate to be slightly smaller. We want to scale it in the X and the Y axis, not the Z axis. We actually want to make it a little bit bigger in the Z axis, and I'll explain in a sec why. But we have a thing here called scale instance. Now I could have done scale elements, but what that will do is just scale the faces, which we don't want, or the edges, depending on which one you select. So just to show you that why you wouldn't want to do that, if we then do that, it then kind of doesn't treat it as one object. What we want is scale instance, and actually to do that in the first place we have to convert all of our individual geometry, because even though it looks like it's one shape, it's actually treated separately. We want to treat this as one solid shape, and so then you convert that to an instance. So that means then when I get my instance, if for example I scale in the Z axis, woohoo, it goes all over the place because my origin of that scale is still set to be 0, 0, which is just down here. So for example, if I change X-axis, that doesn't matter too much, but you'll see it's now treated as one single object. So there's a couple of things we need to do. First thing we want to do is set the center. So the center of the offset is actually going to be our height. So we can get that, and we're going to add that into a combine X, Y, Z, and we want it to be the Z part. So our center now, if I scale in the Z axis, notice it's scaling and treating the bottom as the center of that scaling, which is wonderful. And then we want to have our scale defined by, again, some other generic factor. So let's just create a new thing here, which will scale both in X and Y together. Or I can't drag across, so actually let's just add a new input over there. We'll call that, I don't know, let's call it roof inset is a sensible name. And then go 0 to 1. And that roof inset is going to be used in a combine X, Y, Z again, but we're actually going to use it both X and Y. So that's going to define our scale. And we're just for now going to set Z to 1 as a quick demo use case first, just to show what this is doing. And our roof inset, for example, if we set this as 0.5, what this is now actually doing is scaling in the X and Y by 0.5. So we now have our big shape and we have what is going to be our inset, and we're going to use that in our Boolean. So there's a mesh Boolean operator, and we're going to do the difference. So we want the difference of our base shape, which is going to be mesh 1, and then we want to subtract mesh 2. And at the moment, you'll notice it doesn't do anything. And the reason that it doesn't do anything is because they're both perfectly the same height. And so what we actually want to do is just increase the height of the thing we're cutting out, just so that you get the calculator is just a little bit more efficient. If you treat it as perfectly the same size, it struggles sometimes. So now you get a really nice idea of, if I have an inset of 1, it really breaks because it tries subtracting basically itself from itself. But if you do it as 0.95, for example, you get a really small roof kind of inset on the top. And then rather than having that piece of the roof come into the join geometry, let's have that. And so now we have this nice little detail on top. And so we can have our roof inset. And by the way, when I'm dragging here, you can just drag with your mouse, but it moves quite fast. So sometimes if you just want to hold shift down, it goes a little bit more gradual and you get a little bit more control over it, which is a little bit nicer, especially when you're working with such small numbers like we are here. We're just kind of working in a scale of 1 by 1. So yeah, that's a neat little feature to keep an eye on. But yeah, we now have our base shape and we have our roof. So I'm going to do similar to the thing what I did before. Group all these guys together, Control J, and make our nodes nice and neat. So this guy is going to be called roof. So now we have the base shape done, we've got our roof done. We're next going to add some extra details to that base shape, and to do that we're actually going to use the base shape here rather than what we've got with the joint geometry, and we're going to take the base geometry and we're going to turn it into an instance, because we're actually going to scale it. And if you recall correctly from the previous examples that I've gone through, in order to scale stuff, when we want to treat it as one object, we turn it into an instance first, which then treat it as one single object rather than individual faces or indexes and stuff. And then we're going to scale that in the X and Y axis. And we're only going to scale it a little bit. And then link that instance up to there. And just so we can see what we've got and what we're working with. And as we're moving around, you can press 5 to change this to orthographic. And then 1 or 3 will give you front and side views. And the reason I've done that is just so that you can see the difference here before we scale and after we scale. And what that is going to allow us to do is we're going to take this bigger shape and make some cuts in it with some more booleans and actually make our steps, and then add the scaled shape, which is then going to have cuts on it, to the base shape, and then that will give us some nice stepping. So it's essentially going to be 2 shapes on top of each other, but it will, at the end of it, look like one. So now we've scaled it, we can turn it back to geometry again, so we can just do realize instances, and that's what then will go into our Boolean. So we can set up our Boolean to start with, and then we can start defining our steps below, where we will put our steps into here, or our cubes that will make our steps into here, and then the result of that Boolean will actually then come into our joint geometry. So at the moment, what we've actually now just done is create that base. We've actually got the full shape, the bigger shape, and the roof. We're going to start cutting away at the bigger shape to then make some nice steps. Now to do that, we're actually going to require a a little bit of, I'm going to say complex, it's not too complex. We're going to create our own group. We're going to create our own node, essentially. And it's a piece of functionality that we are going to use now, and we're also going to use it again later on when we add some other cutouts, which is going to be array functionality. And it doesn't come in by default. There's a couple of different ways you can do it in Blender. But the way that we're going to do it is we're going to create a group, and we are going to first start off with a duplicate elements node, which is going to take a base shape, i.e. a cube, and then we're going to duplicate that a certain number of times. So let's say we did it 3 times as an example. And each of those different things we're going to set the position of, but we're going to set the position of the first thing at kind of 0, 0, and then the next one's going to be a little bit higher, and the next one's going to be a little bit higher above that. And then what that will do is we'll create some steps that we can then use as booleans. So the way we can do that is we have our base geometry, which is just going to get fed straight into set position. And then we can use our duplicate index, which will go 0, 1, 2, 3, 4, depending on the number of things in that array. And we can multiply, math node, then multiply. That duplicate index. And we're going to create our own little group in a second, but I'm just setting up the base of that group. Actually, we do it now. If you highlight the thing you want to go in the group, and then you hit Control G or Command G on Mac, and it then sets you a kind of it's standalone nodes. It looks exactly the same as the geometry nodes, but it's just a standalone group. And that group then allows you to have its own inputs and so on. So we're going to have the geometry as one piece of input, the thing that we're going to make an array of. We want to have the amount, the number of things in our array, and we're just going to call that count. Then the next things that we're going to have are what we call the multiply, and then the multiply is going to give essentially the distance between the different steps. So I'm going to call that to start with. I'm just going to call it gap. I might end up changing it depending on how it functions. And then what we're using here is, let's say we have a cube, we then have another cube and another cube. We need to define the direction of that as well. It could go up, it could go left, it could go right. So we've now got a scale of the number of the size of the step we want to make, and then what we then need to do is, rather than a math node, we need a vector math node, and that allows us to do math in 3 dimensions rather than just a single dimension. And we can then multiply here as well, and the input of that is going to be a vector. Although actually I'm going to leave that off for us. Actually, I can just do it because I can do it from on the side. And then that is going to define our offset, and the output is just going to be the resulting geometry of that duplication. So we now have a single piece or a single group here. And if you press tab, you can come back out of that. So now we've got our node with our custom defined inputs and our output as a geometry. So just to show you what this is going to look like. If we give this thing a cube, which conveniently is actually what we're going to use anyway, so that's quite nice, pass that into our geometry, and we're just going to take a little look and see what comes out of this geometry on the other side. Although, remember again, we're going to need to put a geometry to instance on this, because this is duplicating a whole instance rather than just that, although that is just duplicating the vertices, which suggests to me, yep, there it is, duplicate elements. That should actually be instance, and so then at that point it now will duplicate, depending on the count, the gap. If it's, as an example, do 1, and let's send this in the y-axis, and there we go. So what that's now doing is it's multiplying this number by this 3-dimensional vertex. So if I make that gap 2, there, I mean, you can in theory do 2 here or make that 4, but the best way of using this is just this defines your direction, this defines your gap, and then your count will just be the actual number of times that you're using that. So here now we can start modifying the shape of this cube such that we can get some steps, and the way we're going to do that is we're going to use our group input, because this is going to be something we want driven by that right hand side, or the actual the geometry nodes over on this side, and we're going to have a thing that defines our size. Now, our size, x and y, doesn't really matter. It just has to be bigger than our base shape, because we're using these as booleans. They just have to be fairly big. The gap, we're actually going to be going vertically here because we're making some steps. So I'm going to go 1, 0 in the y-axis, and our gap is eventually going to be fairly small, but I'm just going to leave it as that for now. That's going to be driven by another input in a moment. So this thing is going to come up here. I keep forgetting you can't do that. So let's go click on here and then on group, add a new input. That new input is going to be called step padding. And the step padding, we're going to do combine X, Y, Z, and this is going to define the size of the cube. Now, the reason it's called padding and not height is because the cube is the thing we're going to be subtracting from our mesh, and I'll show you that in a sec. But that's where we can then define this is 2, this is 2. Our Z is going to be defined over in this thing now, so let's just do that as 0.1, for example. And then when we start subtracting this from our base shape, this will create holes. So if we have a little look at what that's doing, our output geometry can go straight from our array into here. And we can already see it's taken a piece off the bottom. But if we reduce this gap, what we should see in a second, if I come down like high enough, there we go. We're now seeing that the cubes that we've generated here after the array, and if I go into side view, actually you'll see it really well, are now being subtracted from that base shape. So our base shape, our cubes, and that's the result. So now, after our join geometry, we've now got this little extra detail going on with the site, which is actually really neat. The little thing we want to have driven now is, rather than me having this hard-coded gap here, we could have that driven by another input. So the step height, we're going to call that, is then going to define that gap from the right hand side, so we can modify that up and down, and it will then actually affect this particular piece here quite nicely. So I'm just going to quickly capitalize that. The only thing I also want to actually do here is, you'll notice that the if I go to the side view, the first cube is sat like below the shape, and also because it's Boolean, will currently subtract from the bottom, so you kind of end up with this like floating step. If I show you after here, you get this like floating here. I actually want this thing to be always at the bottom. So the way we're going to do that is, the original cube that we use, before we send it to an array, we're going to use a set position. And we're just going to offset that vertically. And so we can do a combine X, Y, Z with a vector. And we're just going to offset that vertically by the step height. So then now we always end up with the cut being nice and square to the ground. Don't need to do that. So then our resulting geometry looks really neat. And actually it's worth us also linking up the count to the geometry as well. So that's just going to be step count. Shift that up so it's the first one. So then now if I increase this, I'm not seeing it because our step gap is too big, but you can hold shift down just to do some small increments, and then that will then allow us to say actually our step height is going to be reduced. So the step height controls this piece. Step padding then actually defines how big a gap you get in here as well. So it is possible to get a bit of weird overlap, but the controls are fairly straightforward. There are better ways of defining an array. You can do it with a curve and split resolution on that, which gives you a bit more control. But for simplicity, this is the easiest node setup from having played around. And actually, that reminds me, I needed to go in here and rename this to be array. And what that means is, now when I go to add stuff, if I go to group, I actually will see my own custom array thing here, so I can use that multiple times. That makes it nice and easy to use. So yeah, we have now got some steps set up, and actually going to then group. I don't want that bit. Let's do that and that. I'm going to shift them down here, and then just do our standard Control J node steps. So yeah, steps controlled, base shape and roof are all in place. So for our last piece of geometry that we're going to modify on our shape, is we're going to reuse a lot of the same kind of functionality and features that we've done before. Build a cube, modify that cube, set some parameters on the right hand side, and then use that as a boolean to kind of cut out further shapes from this. So the first thing we're going to do is, we are, as mentioned and as we've done before, is we're going to use a cube. We're also going to use mesh boolean, And we're then going to use this whole shape that we can see right now. That's going to be our shape from which we will subtract. And then we're going to take that cube and we're going to use, for now, just generic cube just to show a demonstration of it. And we're going to then modify that from the base shape. And annoyingly, sometimes this happens. Done a few test runs on this. Sometimes it happens and sometimes it doesn't. I'm yet to work out why. But if this happens where you do a Boolean and you still see the cube, if you hit self-intersection, I found that seems to fix it most of the time. And now that's actually doing it correctly. If you change width bottom to 0.8, for example, it does it a much nicer. But then actually, okay, it might be clashing because of that width bottom being the same dimension as the cube, possibly. If it does happen again, just hit self-intersection and that does seem to fix it. So let's just try this out with the cube now. What we then want to do is move that cube so that it's then set to take from one side of it. So rather than taking from the middle, we are going to take like a chunk out of here, and then we're going to make a copy of that cube, move it over here, and then take a chunk out of this side as well. So I'm using 7 there to get me a top-down view. So we've got our cube, we set the position, and we're going to set the position to be half of the width of our base, which will then shift it up so that it's then in line with this. So our offset, we're going to use the y-axis to start with, combine x, y, z vector, and that y is then going to go to a group input. So input, group input, and we need width bottom. We want to divide that by 2, so we need a math node, math divide node, divide that by 2, and then that can go into our y-axis. So now you'll notice if I resize this, a little shortcut by the way, hold down shift, drag all 3, and then you can change, and you just have to type 0.5 once and it changes all 3 dimensions. So we've now got our mesh boolean, which is again not working. So we just click the self-intersection back on again, and that seems to be happy. So yeah, I'm really not sure. It's quite annoying, but yeah, it does work if you click self-intersection. The next thing we want to then do is we've got our base shape here. We're then actually going to use a transform. Actually, we could even just use a set position again. We're going to use another set position node. And this time we want to shift it in the y-axis negatively by the width. So we want to take another copy of that width. This time we're going to use a math multiply. Multiply that by -1. Combine x, y, z again into the y-axis. Offset that there. And that geometry is going to come down. So we have our offset there. We then have one on the opposite side. We can then join them together. And now we have both pieces. They're not working nicely. And our mesh boolean now has a chunk taken from that side and a chunk taken from that side. Perfect. So we're just going to shift this up because we're going to do a little bit more customization on the cube dimensions and positioning. But we do have something working where now we have our base shape with a much nicer shape taking place. So the first thing we're going to do here is our cube's dimensions are going to be driven by a group input. And the first one of that is going to be the height. So we could in theory take, rather than just the bottom bit here, the whole thing. So this size we're going to put into a combine x, y, z, and then each of those individual dimensions can be driven accordingly. So let's just put in 0.5, 0.5, and then for now let's just do 0.5 as well, just so we've got something. And we're going to make a new input go into z, and that is going to be called cutout height. And now let's just set a minimum of that, probably 0 and 10 is going to be plenty. So now if we increase this thing, we can actually take out a chunk from the whole side. Do notice you get some weird stuff happening with the roof, but it still does add part of a roof there anyway, so it's not a disaster. So yeah, just set that back to the 0.5 for now. The next thing I also want to be able to control is the offset of that position. So at the moment, it's automatically centering itself to be level with the width. It would be nice if we could control how far in or out that is also happening as well. So, and also the width. So actually, let's do width first, which I think is that factor there. Yes, it is. So if we do cutout width is going to go into X. And let's just call that R1, for example. Or even actually a 0.1. Might be quite a nice little kind of doorway type cutout, which works quite nicely. That gives us something to work with. And in terms of the Y, that's then going to be our cutout depth. So we've got our height, width, and depth all defined as features here. So cutout depth, if I can spell, will then also allow us to control how far in that cutout actually goes. So, for example, we could, if we wanted to, just take out a smaller section. But for now, yeah, 0.5 is fine. We've got that. We've got that on both sides. It would actually be also cool, and again, you would have seen this in my videos. If we can change this position vertically, which we already have our set positions here, but we're going to do this on both sides. So after the join, this is going to affect both sides of our thing. We're going to have a new offset, and we can just duplicate that group input down here for making the nodes a little bit nicer. That's going to go from this way into, again, combine X, Y, Z. And that Z is going to then be driven by a new group input. That Z is then going to be called cutout Z offset or something along those lines. So then when I change this, that cutout now also can go vertically. So if we want to then change our cutout height to be something like 0.05, we then get a more of a window effect rather than a door. And we can actually then position that accordingly. Again, you can get creative. You've got loads of different parameters now that's going to be able to customize this geometry, which will work quite nicely. So the last piece of customization for the geometry that we're going to do is with the cutout for a window or a door. We're actually going to try and make multiple of those in a given row, consistently in the x-axis for our example here. The way that we're going to do that is we're going to actually modify some of the nodes that we've already created. So we're going to utilize the cube. So if we preview what we had here, then we can see that we've got our cube that goes straight through given the cutout dimension so far. We're going to duplicate that multiple times along a curve, and the way that we can do that is first off we're going to add a curved line which will define where the cube is duplicated. So we can then do an instance on points which will then take the points of that curve and add a cube for every point on that curve. So for example, if we just take in our default curve right now, we take in our mesh in the instance piece and we have a little preview of what we've got. Our curve right now is just a vertical line. It goes from 0, 0, 0, 0 to 0, 0, 0, 1, and the cube is then duplicated on each of those points. And if we want multiple of them, we can resample that curve and then define the number of points. The default value for this is 10, but if we did 2, for example, it's where we were previously. If we did just 1, it's at the very, very start. 3 gives us 1 in the middle. So then what we need to do is make sure that this duplication, or the array as such, is in the direction that we want. And given that our cube is here, currently we're setting the position and then mirroring it in the x-axis to then join them together. We want to actually duplicate. Kind of duplicate that array in the x-axis, and we'll offset it accordingly. So, in order to do that, we are going to add a combine x, y, z, and then we're going to define this x, y, z as the starting point, and the starting point is actually going to be defined by the width of our base object. So we want one point to be in the kind of far corner, and then the end of the curve will be in the other corner. So for us to do that, we need a group input here, and cutout width will be x. So just check to see what this looks like. Why has that not worked? Cutout width x, width is 0.1 right now. We want the width to be, sorry, I don't want cutout width, do it. I want bottom width, that's why. That's a bit better. But we don't want to go width because actually the width is then centered around the middle. So we actually want width over 2. So if we go for a math node and do multiply by 0.5, perfect. Then now when we have our curve line, at the moment it's going from here. We also want to have that at the end as well, but we're going to have that mirrored. So rather than just injecting that into the end, we can then do a vector math. Multiply that vector in. The vector coming out is then going to be mirrored in the x-axis, so we want to multiply the x value by -1. There we go. So now that should line up nicely to our actual base geometry. So if we take the geometry from here, there we go. So that's now centered quite well. So instance on points is good, and then rather than setting here, we have the offset in the y-axis of our base cube. Just going to get rid of the preview of that value. Rather than doing cube, we've set a position there. We're actually now going to put our geometry to be that array, so that now when we do set position, it duplicates there, it joins them, and then it moves them up, and then hopefully the mesh boolean will actually be doing the one in the middle, which is good. The problem we have now is these are set by the base width. We're then moving them in the z-axis, and so actually what's happening is we're slightly missing our geometry, I think. So there's another factor that we're going to add, which is rather than just taking the width exactly as it is, we're going to have one more factor defined as a group input. It could be a little bit smarter about this, taking the height, interpolating it so that it always has a little bit of padding, but for the simplicity of a tutorial, I'm not going to do that. If I, for example, just reduce this value, what you'll see is that these geometry comes in and tucks in itself. That value, what's a sensible name for that? Cutout total width. I guess where cutout width is the individual element, which we can increase still, and then the total width is the actual, the full piece per se, and that's already replicated on both sides, which is great. And at most, total cutout width, we don't want that really exceeding 0.5, because otherwise it's then going to be bigger than the maximum. We don't want it going less than 0. So that's all good. Instance on points is good. Set position is good. We are now doing mesh boolean. Let's just double check we are where we need to be. And the only thing that this will now actually, let's also add this to be a group input here. So the number of duplicates, so we can call that cutout count. Count. I'm so careful about misspelling count that I misspelled cutout. Right, cutout count. So now if we go to 2, for example, we get just the one in the middle. The thing I'm not a great fan of at the moment is if you do 1, you are then only at the start of the curve. Ideally, this would be centralized. And a neat little trick I came up with for that is using a scale and a switch. So where we currently set our x value here, we could instead scale that by either 1, which would be the default, or 0, depending on whether or not this value is 1. So the way that we can do that is a switch. The cutout count is going to go into a compare, and we want it to check to see whether it's equal to something. So we're going to say, is this equal to 1? That will then result in a true or false output, a Boolean output, and that switch will then define whether we go for a false or true thing. And the outputs we actually want to be also an integer. It's going to be 0 or 1 as an output. Redo that switch. So if that is equal to 1, that's going to come into true, and we want to multiply the whole thing by 0. So then we can do a vector math node. Actually, don't even need a vector math node. We can just use a normal math node here. Multiply is actually what we want, so that's good. And we can put the output into here, and you'll notice that centralizes now. because what's happening is the 1 is coming into here, it's compared to 1, so therefore it's true. It's coming into true, which is 0, so it's actually just multiplying whatever x value we find divided by times by 0, i.e. centre it. If we had it as false, and we then increase, so it's set false to 1, it's just going to use the default value that we've given it, i.e. the total width divided by 2. So now when I set this to be 2, or 3, or 4, it's then centralised properly, which is a nice little neat trick. So we've now actually got all of the geometry in place. I know this doesn't look exactly like what we would have shown at the front of the demo, mostly because we haven't got materials on there, or lighting or any of that kind of stuff. So I am going to quickly cover that. Is worth noting though, the shader that I'm using is a paid shader. It comes from a channel or an artist that I'll share, Rasmus Poulsen, who's in Tech Nouveau, who does incredible shading work. I will link to his work in the description. But for now, what I'm going to do is jump over to the shading tab and be confused why there's just a rectangle. That is going to be because my output, so there's a difference here between group output and the viewer output. My group output is actually what gets rendered in my proper viewport. This viewer is just whilst you're in geometry nodes, and giving you an insight to kind of debugging so you can pick it in different nodes. So now if I go back to the shading tab, there we go. That is now working. Now something you will notice with geometry nodes is if I change this material, for example, I just change the color, then nothing happens. And the reason for that is all of this geometry is actually created inside my geometry nodes. So to actually define what material I want to use, we can go and add a new node here called material, set material, and I'm going to not define that one, I'm going to add a new one. And in here, actually, let's go to shading. I'm going to go to my asset browser and show you a breakdown of source list. Don't need the details. And I have saved a couple of Tech Nouveau materials that are quite frankly excellent. So if I just, for example, put that on and drag that onto the asset, it binds it here, it doesn't update the viewer, but what that does then allow me to do is select it from here. So if I select Metal Tech Nouveau, turn that onto shading mode, and actually update the geometry nodes viewer as well, you can see that material is now applied with some funky UVs. But yeah, back in my shading tab, we're looking good. If we go into cycles, it's okay. However, it would be great if we went into the world and set ourselves up a nice proper HDR. Again, I have a HDR set up, so I'm just going to drag that in from my assets. Jump over to my camera settings, film transparent, so I just see the actual geometry and nothing else, and I will quickly show you this. This is a fairly standard HDR setup. It's a HDR I would have found online, and I've set up the strength to be fairly high. I can drop it a little bit if I wanted to, but yeah, that works out fairly nicely, and that will be much more in line with the just switch to orthographic mode as well, just to show you a little bit clearer. If I go back into my object shader and actually just double check, yeah, that is the material there. It's just a texture, nothing too fancy. The only thing I also need to do is switch to cycles and GPU, and then suddenly this will look a little better. The Tech Nouveau shader that I used uses, where is it? Dot product, multiply, noise textures, ambient occlusion, which in the version of Blender I have right now, it may have changed in future versions. I think I'm on 3.5 at the moment. Ambient occlusion only works in cycles, but it gives it a really nice kind of like sand gathering effect in here. And then consequently, this is our geometry. So we can go in here and change the bottom height. Sorry, let's go and change the height, for example, make it a little bit shorter, 0.5. Although I did notice, if I change that back, we're getting this weird black artifact on the top. And the reason for that is to do with our booleans. We have two overlapping booleans. We have this one, sorry, no, we have the base shape here, if I come out of that, and then we also have the result of the booleans. And when you combine them, because their geometry here is exactly overlapping, sometimes you get these weird artifacts, i.e. in this case it's just a straight black. The little trick we can do is where we had our scale instances earlier that was taking the base shape and expanding it out to then do our booleans. If you change the z to be like 0.99999, it still treats it as 1, but it does mean you don't have exact overlap, and then you get to see the output. So now if we change our geometry from our geometry nodes, so height 0.5 for example, we can change our cutout height. Let's go a cutout height of 0.25, and then z offset of 0, and cutout height of 0.5, something like that. Yeah, we're starting to now get the Dune-like buildings, which is working really nicely. And that is everything I had to cover in the tutorial. If you do have any questions, please feel free to send them over to me. I would also love to see your work variations of what we've done here. Hopefully you can use a lot of the foundational kind of points and the tricks that we've used to build your own variants of procedural sci-fi buildings. It would be great to see them. Please do send them over, Joe Pavitt 3D, on Twitter and Instagram and YouTube and all that fun stuff. But yeah, I hope that was useful. And yeah, see you next time.